Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practical 1 Volumetric Analysis. In the present module we are discussing Experiment 6, that is estimation of ferrous ion. The contents of this module are introduction about dichrometry, aim of the experiment, principle behind the experiment, reagents used for the present experiment, procedure, that is preparation of standard more salt solution, standardization of K2Cr2O7 and estimation of ferrous ion. Finally, results of this experiment. First of all, dichrometry. You are familiar with the most powerful oxidizing agent, potassium dichromate in acidic medium. The oxidation reactions can be utilized in volumetric analysis. If you are taking potassium dichromate as an oxidizing agent in volumetric reactions, then you can call it as dichrometry. That is, dichrometry is the redox titration method that uses potassium dichromate as the titrant or oxidizing agent. It is one of the most common and convenient redox titrations due to strong oxidizing power of acidified potassium dichromate. Potassium dichromate acts as a strong oxidizing agent on acidic medium. K2Cr2O7 is a primary standard in volumetric analysis. That means this fixed quantity of potassium dichromate can be weighed out and can be used in the preparation of the standard solution. That is why it is considered as a primary standard. Thus, a standard solution of K2Cr2O7 can be prepared and can be used for further titration. Generally, dilute sulfuric acid is preferred as the acid medium. During the reaction of K2Cr2O7, Cr plus 6 in its original state is reduced to Cr plus 3. This is the reaction responsible for the oxidizing nature of potassium dichromate in acidic medium. That is, K2Cr2O7 plus 4H2SO4 produces K2SO4 plus Cr2SO4 thrice plus 4 molecules of water plus 3H2O. There are two types of indicators for dichromate titrations. They are external and internal indicators. Now, the aim of the present experiment. The aim of the experiment is here to estimate the amount of ferrous ion in the whole of the given solution of ferrous sulfate. An approximately 0.1 normal solution of potassium dichromate and Ar more salt are supplied with. The principle behind the experiment. A standard solution of more salt is prepared and potassium dichromate is standardized by titrating a measured volume of the more salt solution against potassium dichromate. K2Cr2O7 plus 6 FeSO4 plus 7 H2SO4 produces K2SO4 plus Cr2SO4 thrice plus 3 Fe2SO4 thrice plus 7 molecules of water. That is why potassium dichromate acts as an oxidizing agent in this reaction. It is very well clear that ferrous sulfate present on the left hand side is oxidized to ferric sulfate. That ferrous to ferric conversion is achieved by acidified potassium dichromate. The equivalent mass of more salt is same as its molar mass. More salt is ferrous sulfate, ammonium sulfate, 6H2O. Its molar mass equal to 392, which is same as the equivalent mass. The given ferrous salt solution is made up to a known volume and a measured volume of the solution is titrated against standardized potassium dichromate. From the titer values, the mass of ferrous ion in the whole of the given solution can be calculated. The equivalent mass of ferrous ion is same as its atomic mass, that is 55.85. Now, we are discussing the reagents required for the present experiment. Reagents required are number 1, Ar more salt crystals. This is used to prepare a standard solution of more salt by using which we are standardizing the given potassium dichromate solution. Number 2, approximately n by 10 K2Cr2O7 solution. Number 3, ferrous sulfate solution, which is used for estimation of Fe2 plus ions. Dilute sulfuric acid, N-phenyl andranilic acid indicator. Now we are discussing the procedure of the experiment. The experiment consists of the following steps. In the first step, we are preparing a standard solution of more salt. That is, preparation of standard more salt solution is the first step in the experiment. The second step is the standardization of K2Cr2O7. For this, we are performing a titration between K2Cr2O7 against more salt. Last part of the experiment is estimation of ferrous ion, and for this we are titrating potassium dichromate against given ferrous ion solution. We are entering into details of the experimental procedure. First of all, we are discussing preparation of standard more salt solution. The mass of more salt required to prepare 100 ml of n by 10 solution can be calculated by using the expression weight required equal to VEN divided by 1000. As you know, V represents the volume, E represents equivalent weight, and N represents the normality. On substituting, the volume is equal to 100 ml, equivalent weight is equal to 392 ml, and normality equal to 0.1. The three things multiplied and divided with 1000 to get a mass of 3.92 gram. That means the amount of more salt required to prepare 100 ml 0.1 normal solution will be equal to 3.92 gram. Now, roughly weigh out 3.92 gram of more salt and transferred to a dry weighing bottle. It is then weighed by an electronic balance accurately, and the weight is reported as W1. The substance is now transferred to a 100 ml standard flask through a funnel and make up to the solution by adding 10 ml dilute sulfuric acid and water. Remember, here we are adding dilute sulfuric acid, and it is essential to prevent the hydrolysis of the ferrous salt solution. Now, the weight of the empty weighing bottle is again recorded using the electronic balance, and it is noted as W2. The actual weight of more salt can be calculated as W1 minus W2. The weight W1 minus W2 is used to find out the concentration of the more salt solution as normality of the more salt solution equal to weight per liter divided by equivalent weight. Now, we are entering into the procedure of the second part of the experiment, that is standardization of potassium dichromate. Remember, here we are performing a titration between more salt, that is the standard more salt solution, against potassium dichromate. Here, conventional titration procedure is adopted rather than the double burette method of titration. Fill out one burette with potassium dichromate. 20 ml of the made up more salt solution is pipetted out into a conical flask and add 50 ml of dilute sulfuric acid along with the 10 drops of N-phenyl andranilic acid. You have to remember the fact that N-phenyl andranilic acid is used as the internal indicator in this reaction. So, you got a mixture of 20 ml of more salt along with the 50 ml dilute sulfuric acid and 10 drops of N-phenyl andranilic acid. It is then, the solution is then titrated against potassium dichromate and end point is determined. Here, the end point is noticed by the color change from green to violet red. This color change is the indicator color change of the indicator N-phenyl andranilic acid. Now, repeat the titration for concordant value. You are familiar with the concept of the concordant value. Concordant value means in two repeated titrations, two adjacent titrations, you should get to the same value. That value is considered as the concordant value of the titration. Now, standardization of K2Cr2O7 demonstration. Hereby, we are demonstrating the standardization of K2Cr2O7 using a standard solution of more salt. Over to expression for concordant value. Thus, we have completed the experimental part of the standardization of K2Cr2O7 and now entering into the calculation part. The weight of more salt taken is equal to W1 minus W2 and that is equal to 3.962 gram. So, in the experiment, to prepare the standard solution of more salt, we took a weight of 3.962 gram. Weight of more salt per liter of the solution will be obtained by multiplying 3.962 with the ton. This is because you transferred this weight into 100 ml and made up to 100 ml in a standard flask. That's why the weight per liter is obtained by multiplying with the ton. So, the weight per liter of the more salt is equal to 39.62. Now, it is possible to calculate the normality of the prepared solution by using the expression normality of more salt is equal to weight per liter of more salt divided by its equivalent weight. That is 39.62 divided by equivalent weight of 392. You will get a value 0.1011 normal. Thus, we got a standard solution of more salt with the concentration 0.1011 normal. Now, we are dealing with the calculation part. Continuing, the titer values can be tabulated as follows. This is the titer values obtained during the titration between more salt and potassium dichromate in a single burette method. Serial number, volume of more salt, burette reading and volume of K2Cr2O7 obtained are depicted here. And the concordant value of the titration will be equal to 20.1. So, you got a concordant value of the titration, that is nothing but the volume of potassium dichromate, which is taken as 20.1. We can continue the calculation. From the titer value, we can calculate the normality of K2Cr2O7 by using the relation N more salt into V more salt is equal to N dichromate into V dichromate, and here N more salt is equal to 0.1011 normal, that we already calculated, and the volume of more salt taken by pipetting out is equal to 20 ml, and volume of potassium dichromate used, that is from the concordant value, which is equal to 20.1 normal, and we get the normality of potassium dichromate from this equation by proper substitution as N K2Cr2O7 is equal to 0.1006 normal. That's why we have standardized the given potassium dichromate solution by using standard solution of more salt. Now we are discussing the procedure of the last part of the experiment, that is nothing but estimation of ferrous ion. The given solution is made up to 100 ml in a standard flask and 5 ml dilute sulfuric acid is also added during the makeup. This is to prevent the hydrolysis. 20 ml of this solution is pipetted out into a conical flask and add 50 ml dilute sulfuric acid along with the 10 drops of N-phenyl andranilic acid indicator. Now, the solution is titrated against potassium dichromate taken in burette and end point is determined. The end point is the color change from green to violet red. Repeat the titration for concordant values. From the titer values, the amount of iron in the whole of the given solution can be calculated. Now we are demonstrating the estimation part of the experiment. That is, we are demonstrating the estimation of ferrous ion. Over to the experiment. titer value from the burette. Now place the burette back, record the titer value and repeat for concordant values. Now we have completed the experimental part of the estimation of ferrous iron and now entering into the calculation part. The titer values can be tabulated as follows. This is the titer values obtained during the titration between ferrous salt solution and potassium dichromate. You can see the volume of ferrous salt pipetted out in 3 titrations is equal to 20 ml. From the initial and final burette reading, you will get the volume of K2Cr27 used and the concordant value is equal to 19.8 ml. Thus, from the titer values, we can calculate the normality of ferrous iron solution using the relation N1V1 equal to N2V2, where N1 stands for normality of ferrous salt solution, V1 represents volume of ferrous salt solution, N2 is already known, that is equal to 0.1006 normal, which is the normality of the K2Cr27 solution. V2 is equal to 9.8, that is nothing but volume of potassium dichromate. N1 is obtained by N2V2 divided by V1, and that you will get a final value of the normality of the ferrous salt solution as 0.0996 normal. Now, weight per liter of the ferrous ion in the solution can also be calculated. For this, we are using the expression weight per liter is equal to normality into equivalent weight. Normality you already got as 0.0996 normal. Just to multiply it with the equivalent weight of iron, that is nothing but 55.85. On multiplication, you will get a weight per liter of the ferrous ion solution, that is equal to 5.5626 gram per liter. Now, mass of ferrous iron in the whole of the given solution can be calculated by using this equation, weight per liter divided by 10. The number 10 is because of the fact that previously you made up the given solution to 100 ml. That's why to get the weight of ferrous ion in the whole of the given solution, you have to divide weight per liter with the 10 and you will get a value of 0.5563 gram. And the final results are consolidated like this. The normality of the given ferrous salt solution is equal to 0.996 normal. The weight per liter of the ferrous ion in the solution is equal to 5.5626 gram per liter. And finally, mass of ferrous ion in the whole of the given solution is equal to 0.5563 gram. Thus, we have studied about estimation of ferrous iron using potassium dichromate. That's all about the present experiment. Have a nice learning experience. Thank you.